Okay, so question 9, right? What we need to do here, we need to use the algebraic method, and then we will just add up equation 1 and equation 2. Equation 1 being the first one, then this is your equation 2. Okay, so just look for the species, right, that are actually in equation 3. This is the delta H1 that we need to look for. Okay, so if you look at your carbon, right, it's already in equation 1. So it can stay as it is, right? And then equation 2, if you need the carbon dioxide, right, you need to flip equation 2. You cannot flip equation 1 because carbon solid is on the left side. Okay, so we're going to flip equation 2 so that we can get 2 iron solid plus 3 carbon dioxide. If you iron 2O3 solid and 3O gas. Okay, so we're gonna just flip it and call it maybe like 2A. Okay, so after we add up, you realize that you can cancel out. Oh, sorry, you need to multiply 2A by 2 first. Okay, so this becomes like 6, becomes 2, this becomes 6, becomes 4. Okay, so that you can cancel this guy out. So this guy out. And then you can get 3 carbon dioxide here. So cancel. You get 3 CO2. Then 4 iron cancel out nicely. Okay, so what you're left with, right? You're left with 3 CO2. Then you're left with, okay. So when we add up 1 and 2, right? What will you be left with? You're left with 3 carbon solid. Then you're left with 3 CO2. Okay, and then product you're left with 6 O gaseous. Okay, so this is like if you look at the final equation 3, right? In order to get to this, you will need to then divide by 3. Okay, so your manipulation, right, is fairly simple. All you need to do is to just reverse the second enthalpy, reverse and multiply by 2. Okay, then you add up their enthalpies. The final answer, you just need to divide it by 3. Okay, then you get your delta H1. Okay, which is what the work solution actually did. So after you multiply it, you will get this answer. And then after that, you just divide it by 3. You get your final answer here, 172.5. Then answer is C. Okay, using algebraic method is probably much easier than using the energy cycle method. So if you want to, you can still use the energy cycle, but you have to add in your carbon dioxide on both sides of the equation.